In today's lesson, we're going to be talking about the refraction of light, which is another property that we're going to describe when we're dealing with waves, and specifically with light waves. Now, I'm going to show you an example of what refraction is, and here I have a straw inside a beaker. As you can tell, the straw is not bent at all, and as I put it into the cup of water, my beaker of water, look what happens at the edge. The straw, in essence, looks like it's bent. Right there you can see the bending. It doesn't look like it's straight anymore. It looks crooked, but again, it is not. If I put it straight in, it starts already looking somewhat bent, but it's not. And this refraction gradient, or this bending, see right there, you can really see an exaggerated point of view. This bending of light, quote unquote bending, is caused by two different phenomena. It is caused by the slowing down of the speed of light and a change in the wavelength. This is known as refraction, the bending of a wave as it encounters a medium. Now, how much this bend occurs depends on the density of the medium. In the case of my beaker full of water and air, air is less dense than water. So the straw looks bent because as the speed of light goes from the air into the water, it slows down. We know this as the Snell's law and the index of refraction. But as the light enters at a 90-degree angle, in other words, straight or perpendicular to the boundary or wherever it's hitting, it will encounter this more dense material, and it causes it to bend or slow down towards the line that would be straight up and down, the normal line. If it is less dense, say the light was traveling out from the water into the air, then it would bend away from the normal. This is caused, again, because as it's going through a more dense material, think of it in terms of the light has to push its way through instead of it just going normally through. Now, we have two ways of calculating this index of or this refraction gradient. The first thing we look at is the index of refraction. The index of refraction is a value that compares the speed of light, or C, to the changed speed of light. It's a ratio between the two. So N is the symbol we use for the index of refraction. C is our velocity, or the speed of light. And V is the velocity at which it changes as it's going through a new medium. Snell's law is the way that we can predict by how much this angle is going to change. So we have the index of refraction, or the N value that we can calculate up here, of the initial speed or the initial light, and it's multiplied by the sine, one of those trig functions, the sine of the angle, the initial angle I, is equal to, should be equal to the N of refraction. In other words, the changed N value times the sine of that angle of refraction. In other words, again, the angle of refraction. Here's our initial or original one, and as it goes through, it's going to bend towards this normal line, and that's our angle of refraction. This is used to determine how much that bending is going to occur. Now, I can explain also why we see a rainbow effect in our raindrops or in water droplets. As white light, here in purple, I couldn't put white because then you wouldn't see it, but anyway, in purple, this represents all the colors that white light has, all the light colors. And as it goes through this raindrop, the wavelengths start changing just slightly, and therefore as it comes back out, it causes the separation of all the different colors in that we see. Here I represented the red, the green, and the blue, which is the longest wavelength, suffers the least amount of change, compared to a middle range wavelength, which is green, that suffers a little bit more of this quote-unquote bending. And then one of the shortest ones, which is blue, next to indigo and violet, causes the greatest change in this angle of refraction. And so as white light goes through, we have a change, a little bit of change in our wavelength. It makes it a little bit longer or shorter, and it causes the separation as it goes out. So this is another property of light that we will be discussing as we go through, and you'll see how this change in direction of light, you can think of it in those terms, helps us with things like glasses, like the ones I have on now, or in other things like microscopes and other places where we would use a lens that causes a change in the speed of light as it goes through such materials.